All right, so we are learning about factoring linear expressions. And so this is the opposite of the distributive property. So remember, we learned the distributive property, and I know some of you are still struggling with that. So this is just an example, okay? So when you have 2 times 3x plus 5, okay? And we distribute that 2 to both things. So this becomes 2 times 3x plus 2 times 5. It has to go to both items. So then we end up with 6x plus 10. So that's the distributive property. Factoring is working backwards. So you're going to start with something that looks like the 6x plus 10 and go back to the part with the parentheses. Okay? So we're going to learn how to do that. So it says, how do models help you factor linear expressions? So Max has enough 1-inch square glass tiles to create a rectangular piece of mosaic art that has an area of 24 square inches. Okay, so we're looking at a rectangle, and the area is all the space on the inside. Okay, and so area is base times height, or length times width. Okay, so the length and the width. So some of the possible dimensions of the rectangle are listed in the table. Write the 2 missing possible dimensions. Okay, so remember, area is length times width, right? So if we need a total, if we need the area to be 24, then if we multiply, we should get 24. So 3 times 8 is also 24. Okay, 4 times 6 is also 24. And 2 times 12 is also 24. And if you don't know your math facts like that, very easily get out your multiplication chart. They're there. So each of the dimensions listed are factors of 24. Sometimes you know the products and are asked to find the factors. This process is called factoring. So when you break it down into its factors. Okay. So we want to use tiles, algebra tiles, to factor 2x plus 6. Okay. So we have 2 x's and we have 6 positive tiles. Okay. So you could rearrange the tiles into a rectangle with 2 equal rows and columns. The total area represents the product. Its length and width represent the factors. So we still have 2 x's and we still have our 6 tiles, but we grouped it in 2 equal groups. So we would say that this is 2 groups of x plus 3. So 2 groups of x plus 3. Okay. Let's look at this one. So we have 2x minus 8. So 2 x's and 8 negative tiles. So again, we would break it up into 2 equal groups. So 2 groups of 1x and 4 negatives, right? This group right here is 1x and 4 negatives. This group right here is 1x and 4 negatives. So you have 2 groups of x minus 4. Okay, so 2 groups of x minus 4. Okay, and it should lead back to what we had, right? So if you have this, and now we use the distributive property that we learned last week. So 2 times x minus 2 times 4. So that leads us with 2x minus 8. Isn't that what we started with? Yes. Okay, let's take a look here. It says draw the tiles to represent 3x minus 6. So let's draw ourselves 3 x's and 4 negatives. I'm sorry, 6 negatives. All right, so it says redraw the tiles into a rectangle with equal rows and equal columns. So the first way to try to do this is to break it up into how many X's you have. So if you have an X here, an X here, an X here, so this is group 1, group 2, and group 3. Okay, so I believe we're going to have 3 groups of something. Now we need to we got rid of these. Now we need to get rid of our negatives. So if I put 1 here, 1 here, and 1 here, I've just gotten rid of 3 of them. And then I put another one, and another one. 1, 2, 3. Okay, so I have 3 rows. And then what's inside each row? An X minus 2, right? X minus 2. And again, to prove that we're correct, if I distribute 3 times X minus 3 times 2 gives me 3X minus 6, and that's what I started with. Okay. All right, so it says, factor each expression by rearranging the appropriate tiles. Okay. So take a look. If I have 4 X's and 6 positives, okay? Well, what happens if I put 4 X's out, saying I had 4 groups? So I have 6 positives. So let's see. 1, 2, 3, 4, 5, 6. Did they all get used? Yes. But do I have equal groups? No. So this isn't going to work. So what can I do? Well, I could take this X and add it to this group. And I could take this X and add it to this group. Take this positive, add it here, and this positive, add it here. So that means now I only have 2 groups, and then what's left in the groups? So in this group, I've got 2 X's and 3 positives. Okay. All right, 5X plus 10. So 1, 2, 3, 4, 5 X's, and then I need to get 10 positives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that works, okay? So here's one group. So inside, I have X plus 2. And then how many of those groups did I make? 5 of them, okay? All right, let's start with the 3 X's. 1, 2, 3, and let's place those 12 positives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, it worked out perfectly. So in one group, I have 1 X and 4 positives. And how many of those groups did I make? 1, 2, and 3. Okay, let's look at the next one. Okay, so 4 X's. And let's see if I can get 10 negatives in there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Uh-oh, I don't have equal groups. So I need to do something with these. So that means I'm going to take this x and put it as part of this problem, and this x and put it as part of this problem. Then these two negatives can come here, and these two negatives can come here. And now I have equal groups. I've got 2 x's and 5 negatives, 2 x's and 5 negatives. So 2 x's and 5 negatives. And now I only have 2 groups that were created, right? Because these went away. All right, let's start with the 3 x's. So 1, 2, and 3. And let's get rid of our 9 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Perfect. So what's in one group? 1x and 3 negatives. And how many groups did I create? 1, 2, and 3. All right, let's start with our 2 x's. And now I need 4 negatives. So 1, 2, 3, and 4. So perfect equal groups. One group had x minus 2, and 2 groups were created. Okay. This doesn't have to be too difficult. Draw yourself a picture. It makes it easier. Okay, let's start with 4 x's. So 1, 2, 3, and 4. And then I have 2 positives. So 1, 2. Uh-oh. I don't have anything else. So that means this x needs to join this one, and this x needs to join this one. Now I have 2 equal groups. So 2 x's plus 1, and that is 2 groups of that. Okay. All right, next one, 5 x's. So 1, 2, 3, 4, and 5, and 5 negatives. 1, 2, 3, 4, and 5. So perfect equal groups of x minus 1, and there are 5 groups of that. Okay. All right, so I'm going to stop this video, and then I'm going to do a few more problems on the next set of worksheets, and then do your assignment.